It's officially 11:40. We can probably get this thing started. It's going to be kind of a little bit more informal. These are the maintainer track, so we'd like to ask questions to the audience, do straw polls, hand raises, and stuff like that. Just by a show of hands, real quick, how many folks know what a SIG is inside the Kubernetes project? All right. So for those who are not familiar with SIGs, it's basically a special interest group. Large open source projects for several years have kind of divvied up different content areas into what they call special interest groups, or people who are focused on given areas. SIG Cluster Lifecycle is kind of a horizontally facing SIG. So sometimes what people see if they look on some type of org chart is vertical facing content areas like storage or networking. Then they see Cluster Lifecycle, which is something that cuts across horizontally because it involves almost all the components in some way, shape, or form. So today we're going to talk about who we are, what we do, why we do it, and basically details of how you can get involved. Right? A part of doing the maintainers track at a conference like this is what makes Kubernetes great is the community and the involvement of those who are in the community. So if you are interested and want to get involved, we welcome all parties, and we'll give you all the logistics at the end of this talk. So who are we? My name is Tim St. Clair. I've been involved in the project since the very, very early beginnings. I think I first met Robbie at a galvanized basement in San Francisco 4 years ago. And since then, I've been involved in many aspects of the project over time. And I'm currently a staff engineer at Heptio / now VMware. And yeah, that's me.
Cool. And my name is Robert Bailey. I work at Google. I joined the Kubernetes team in 2014, in the summer of 2014. Began contributing to open source on some of the sort of cluster bring-up scripts, which are kubeup, which is bash code that's still in the main repo. Not too long after I joined, Google decided to start building GKE. So I was one of the founding members of the GKE team and helped lead that team to launch GKE and help it evolve through its alpha, beta, and GA launches. And I'm a staff software engineer at Google. What's interesting about this talk, though, is it's not really about us. Tim and I are two of the three co-chairs. Lucas is another one. He's sitting in the audience. But the fact is that our SIG is a very diverse, sort of geographically diverse set of people. We have over 550 members on our mailing list. We have more than 20 companies that have had representatives show up over the last 3 months to our primary SIG meetings. So you can see this is not like a Google SIG or a Heptio VMware SIG. It's really got people from all different parts of the project that are interested in helping contribute. We took a quick informal poll between us and counted people from at least 5 different continents that help contribute. So we have people all around the world. If you look at some of our sub-projects and breakouts, they have meetings at different times of the day to help accommodate people who maybe can't make meetings that they're at the US West Coast time when a lot of Kubernetes meetings happen. And we have put a couple of stats here from DevStats about we have over 1,000 people have contributed to projects that are sort of categorized as SIG Cluster Lifecycle just during the last release cycle. So during the last sort of 3 months, over 1,000 different contributors have made contributions and almost 10,000 contributions. And contributions is in quotes because it counts things like issue triage and filing issues and updating issues in addition to sending PRs. But those are all things that are really helpful for the community. Even things like filing an issue because you've read the docs and they're wrong is something that's really helpful and helps our community grow. And then one thing that's really interesting about our SIG is we have a huge number of sub-projects. So Tim mentioned we're sort of a horizontal SIG, and part of what we do is we break our domain into different sub-projects, and those sub-projects often have their own meetings, they have their own leadership, they have their own GitHub repositories, and our SIG is sort of an amalgamation of all of those projects together, trying to solve some cross-cutting issues in our problem space. So here's a quick list of the sub-projects that's listed on our GitHub page. And a lot of these sub-projects are things that we have sort of pulled in from the community that have been started outside of the SIG and have become part of the SIG. So things like BootCube was started as a project from folks at CoreOS and was adopted by the SIG. KubeUp has been in the SIG for a long time. Things like KubeSpray and Minikube are things that we've been pulling in more recently as we've been trying to sort of consolidate all of the folks in the community that are working on the same set of problems.
So what is our mission of SIG Cluster Lifecycle? It's to pass butter, clearly. But it's basically to simplify the creation, configuration, upgrade, downgrade, and overall lifecycle management of clusters. Right? That is a very broad state space of potential solutions and technologies. I like to, it seems beautiful, some of the things that we're doing over time. We're trying to simplify the creation and make things composable and have a clean model. But in reality, it's a ton of spaghetti. And we're de-spaghettifying, which is what started out as independent solutions for different providers and trying to come up with common core composable pieces or a reusable toolbox that can be leveraged by anybody to basically stand up clusters and manage them. So some of the different layerings that exist inside of SIG Cluster Lifecycle, there's control plane installation and management. That's typically done via kubeadm. There's control plane configuration management. Some of the work that Lucas is working on right now, if you're interested in understanding how we sort of manage and configure the actual components, or how we want to versus how we have. I highly recommend talking to Lucas after the talk. It's probably going to be one of the major areas that we're going to be investing effort into in 2019. Then there's simplifying infrastructure management, actual creation of the actual nodes themselves and the machines. This is done via several different technologies. The most prominent one that we are spending a lot of effort on is the Cluster API, and also the different provider implementations for the Cluster API. And the next layer is sort of core add-on management, things like core DNS, the kube proxy. You could also lump in a bunch of other technologies, if you wanted to, into that second layer. Last but not least, we started to, in our efforts to sort of reuse common configurations and tools across different installation mechanisms, we wanted to have a separate layer just for the Kubernetes etcd management. This is still a nascent project, but it's specifically targeted towards management of etcd for Kubernetes itself. So one of the major projects that the SIG sponsors is kubeadm. kubeadm is all about getting the MVP, or the minimum viable product, for bootstrapping the control plane for Kubernetes. What's important to denote is that it's a layer in the cake, right? A lot of folks try to oversimplify or try to lump installers into one bucket or the other. The goal is that all installers at some point in time would try to leverage pieces of the tool chain. So KubeSpray is a good example. Within the 2.8 release of KubeSpray, they have defaulted to using kubeadm as the core component for standing up and managing the control plane. So as I mentioned before, it's a piece of the puzzle. If you want to do infrastructure management, there are other technologies that ride atop of it. COPS is an example of something that does full end-to-end management, and the Cluster API is another one for doing the provisioning aspect of getting your machines in place for managing your deployments. So here's where I'm going to have to be careful not to get on too much of a rant, but like we've kind of done things in the community as being highly opinionated pieces of the puzzle, and then it got us into a bit of trouble, right? Then we started to develop fragmentation. So one of the key design takeaways that we've wanted to distill is that, as I mentioned again, we have a composable architecture, but you want to be able to have a single pinch point for doing the best practices for standing up your control plane. Otherwise, what happened was you would have to replicate the same set of configuration knobs across every single installer. And there would always be some lag or delay that would exist between the different technologies. So some people would miss it. There's other things going on. You just wouldn't be able to catch up over time. And as these things forked further and further down the road, that sort of technical debt would accrete further and further over time. The second most important piece of the puzzle for kubeadm is a simplified user experience. In 2016, Docker Swarm came out as the simplified cluster management solution, and Kubernetes had this weird moniker of being hard to use or hard to stand up. Just getting a Kubernetes cluster running was a difficult thing. One of the primary objectives of kubeadm was just to make it easy, It's the easy button for how you can stand up and configure a control plane. You just basically need two major commands, which is init and join, and it greatly simplifies the process that you need to, or the number of steps you need to do to stand up a secure best practices cluster. The scope is limited, right? I think that's the key piece of this, is like we're trying to follow Unix philosophy. The scope is bounded so that it doesn't accrete all of these other different technologies. And we sort of stop at one line and we make sure that we don't go above it or below it. And then other technologies take it from there, right?
Great. So another sub-project we wanted to highlight today was what we call the Cluster API. If you think back to the slide that Tim talked about a couple of slides ago, and I'll just flip back so you can see the diagram. At the bottom we have infrastructure, which is your physical machines, your cloud infrastructure. So basically these are the machines you want to use. On top of that we have kubeadm, which allows you to take existing machines and sort of manually compose those into a cluster by running, just as Tim was saying, a few very simple commands. But a lot of people want something that's more automated than that. And in particular, we have projects like Kops and KubeSpray, which sort of automate the full sort of life cycle of a cluster. If you look at this diagram, that sort of top layer of the cake is the Cluster API, which is our SIG trying to come together and look at all of the sort of existing projects in our space. We've got Kops, we've got KubeSpray, we've got Minikube, we've got hosted providers like GKE and EKS, and they all sort of offer their own variant on what it means to create a cluster or to create a set of nodes inside of your cluster. And our SIG is trying to come together and create a common definition for what a cluster looks like, what a machine looks like, what a group of machines looks like, and we're calling that the Cluster API. And the Cluster API is really meant to abstract away the differences in the different infrastructure layers across the different parts of the ecosystem. Then there are implementations of that Cluster API that actually sort of provide the glue between that abstract implementation and the actual manifestation of the infrastructure in a particular environment. So since this is sitting at the top layer and sort of provides a full user experience, a user would interact with a CLI, which is called Cluster Cuddle, to provision a cluster. And that will provision the control plane for the cluster as well as the machines for the cluster. And most of the Cluster API implementations are layered on top of kubeadm because we've got this great building block within our community to do the clustering part of the puzzle. But kubeadm explicitly doesn't deal with infrastructure management. So the Cluster API is sort of another layer of the cake that deals with infrastructure management so that you can decide which pieces of the puzzle you want to put together for your particular application or domain. In a similar fashion to how core Kubernetes has pods and replica sets and deployments to have different ways of grouping your workloads inside of a cluster, the Cluster API defines machines, machine sets, and machine deployments to have different ways of grouping your infrastructure to represent your cluster. So a machine would be obviously a single machine in your cluster, but then you can group them into sets. So you can treat a bunch of machines as a homogeneous unit that are easily auto-scaled. This is a very similar concept to systems like GKE or even Kops or KubeSpray, where you have a notion of like a node group or a node pool. And then a machine deployment is a higher level abstraction which allows you to do things like upgrade from one version to another on your set of machines. Some of the design philosophies we've taken with the Cluster API are that we'd like to have controllers sort of following the Kubernetes model that reconcile the desired state of your cluster with where your cluster actually is. This is different from things that exist today like Kops or KubeSpray, which are very much sort of human-driven tools where someone will run, Kops create a cluster, Kops upgrade a cluster, and all of the work is driven client-side by client tooling. And with the Cluster API, we really want to sort of push that into the cluster and let those controllers run sort of as sort of normal Kubernetes services so that instead of running a local command line and relying on your local system to actuate the upgrade, you instead run kubectl edit and set a desired version in your CRD, and a controller will then actuate that upgrade for you. This also has the added benefit that the controllers are running all the time, which means that you sort of inherit things like repair automatically into the system instead of, again, having to do that out of band. The layer between sort of the common code and the cloud providers is relatively small. We have a large number of cloud providers that have started, or people who've started building support for different cloud providers. Some of it's from the providers themselves, and a lot of it's driven by the community. I'd like to highlight here that this list about a month ago was quite a bit shorter, and right as KubeCon China was happening, a couple of the large cloud providers in China very quickly added support for the Cluster API and sort of joined the community, which has been great. And if you want to see an up-to-date list of providers, this list is accurate as of a couple days ago. But if you're watching the recording in a couple of months, you can always visit the project homepage where we link to all of those. And finally, since the Cluster API is sort of a new nascent project, there's a lot of existing tools out in the ecosystem today that we are working on sort of moving them over to adopt the Cluster API. So COPS has its own notion of the way of grouping machines. As I mentioned, they are working on moving over to the Cluster API to adopt the common way we represent machines. Other systems from companies like SAP, like Gartner, are doing the same thing. And I think OpenShift is also moving in the same direction.
So why are we doing this? There are many philosophical reasons for this, and those who know me well know that I can go on long-winded rants, so enjoy. So there are many reasons why, as a community, this is super important to the Kubernetes community, and if you have vested interest in Kubernetes, this will affect you too. From a commercialization standpoint, a legacy commercialization standpoint, the idea of trying to get a secure cluster required you to have a vendor is actually antithetical to the growth of the community, right? And in legacy environments and legacy ecosystems, we won't name names, but we'll call them OpenStack, is that if you leave that outside of the scope of the community's control, and you sort of federate that, the idea of production grade cluster management to vendors, is there's a lot of infighting. They start to divvy and divide, and it's antithetical to the growth of the community. So a primary function of us is to try to unite the community and to build the common set of toolboxes that we use across all of them. This allows us to sort of spread the base, right? So it makes it easier for anyone to be able to run Kubernetes anywhere at any time. We'll talk later on about other sub-projects that have been that are related to SIG Cluster Lifecycle, but to try and help it make it even easier for the development use case. So the whole idea is to sort of rally the community on a focused set of efforts, so that way we can democratize as well as commoditize what it means to have a production-ready cluster. That basically takes away a lot of the detractors from wanting to get involved inside the community, right? Or detractors from people wanting to adopt the technology itself, right? If you have to go to vendor A, and that's a highly opinionated version, and then if you want to be able to transition to vendor B, and that's also a highly opinionated version, it becomes antithetical to your support model because you care about your applications, right? And so by having this common set, this common toolbox of reusable components, it makes it much easier for the community to widely adopt and spread Kubernetes far and wide. So I basically said all this. One part I didn't mention was that with the Cluster API is the idea of managing many clusters, not just one cluster. A lot of times people myopically focus on an individual one, but the Cluster API's real power is actually in being able to manage N clusters over time across Y providers.
Great. So as Tim mentioned at the beginning, one of the reasons hopefully that many people are here is because you're interested in getting involved. And so we want to spend some time letting you know how you can do that. We have put together a document, this top link, if you follow up with the slides, links to Google Doc, sort of describing many of the various ways you can get involved in our SIG. We're always working on growing the contributor and reviewers pool and trying to grow our SIG. As you can see, the SIG is very broad. There's lots of different sub-projects. There's lots of places you can get involved. Each of the sort of different sub-projects has various office hours. So we have a standard bi-weekly SIG meeting where we try to bring everybody together. But then if you want to specifically work on kubeadm or Minikube or COPS or KubeSpray, each of those products has their own office hours you can go to that is specific to that particular sub-project. The Cluster API has office hours both in sort of US West Coast friendly and Europe friendly times. And you can always find a full list of our SIG meetings and times on our SIG page. One thing I also want to point out is you don't have to be a developer to contribute to the SIG. And we're always looking for people to help with project management, to help run meetings, to help curate meeting notes, to do backlog triage, to write documentation, to read documentation, to see if documentation works. I mean, I think one of the things that Tim was highlighting yesterday during the Contributor Summit is that our SIG has spent a lot of time over the last couple of release cycles really trying to clean up our documentation. And a lot of that is not necessarily technical work that requires you to have in-depth knowledge of the code. And it's a great way to get started, where if you want to have in-depth knowledge of the code, helping write the documentation is a great way to build expertise and sort of get to that point. We'd love for people to come help us out and attend our meetings. We have a number of Slack channels. There's the SIG Cluster Lifecycle Slack channel, which is sort of the MUX, where if you go there and ask a question, we can direct you to a different Slack channel if a different place is appropriate. But it's a great place to sort of dip your feet in and get started. If you are looking at a specific GitHub repository or a specific project that you want to get involved in, there are a couple of sort of common labels in GitHub that we try to use to help encourage new people to find where to get started. And so there's a help wanted label for issues where you can look and see, like, where are people saying that, like, there's a need, but nobody's working on this today. On top of that, there's a label called Good First Issue, which is something where someone who's been experienced in the project has looked at it and said, this might be a good place for someone who doesn't necessarily have a lot of expertise to get started, right? A lot of the help wanted issues are things that you already kind of have to know what's going on to really make a difference, because they're bigger issues. But then there are some that are like, this would be an easy bug fix. This would be a small change where someone who doesn't necessarily know how the whole overall project works can get involved from the beginning. We also have a playlist on YouTube where we upload many of the different meetings. So we record all of our meetings. We run on a tool called Zoom. Those recordings get uploaded to YouTube. And so you can follow the YouTube playlist and you can see all the different meetings that we're having. If you can't make meetings, you can watch the recordings later. You can always look at the meeting notes for our meetings. We try to do a good job linking to issues we're discussing, recording things in the notes that people say, which is often quicker and easier to read than going back and watching the whole video. We have a list of many different Slack channels here. You can see they're basically named after the different sub-projects. And again, I'd like to highlight that the first one, the SIG Cluster Lifecycle one, is where I'd encourage people to start if you don't know what you're interested in working on. There is something called the Certified Kubernetes Administrator exam. This is sort of a certification you can get to sort of prove that you understand how Kubernetes works and how you would administer a cluster. You can prepare for that exam. A lot of the material of that exam is sort of based on work that our SIG has done as we've been trying to sort of standardize and come up with secure ways to install clusters. So if you're preparing for that exam and you have questions, you can come ask people. If you are interested in helping make new versions of that exam, getting involved in our SIG is probably the right way to get started. And then you can also check out the various docs that we've linked here. And again, we have a link to how you can get involved to help improve things.
So what's coming in 2019? Basically, there's a lot of different efforts, as we mentioned before. There are many sub-projects related to SIG Cluster Lifecycle. One of the sub-projects that could potentially be a sub-project is better add-on management using bundles, or core add-on management using bundles. What we currently have a problem with is that although kubeadm is great for managing just the control plane, once you step outside of that and you get into the core add-ons such as core DNS, kubeproxy, and other basic installation things that most folks want, is that we start to have the fragmentation again. So bundles is a way of managing or dealing with that next layer of the cake to be able to solve that problem. And as we mentioned earlier too, etcd management can kind of be a little bit thorny. There is a tool that Justin Santa Barbara and the Platform 9 folks, I think it's David Lipinski, had started, and that is still going to be coming. And hopefully over time, we can leverage that tool inside of other tools. We have already talked about the idea of once they have a more mature library, of being able to vendor that library inside of kubeadm to prevent kubeadm from having to do its own etcd management. But again, it's still very nascent at this point. This is one that's near and dear to my heart, more because of pain and suffering. But we want to get a better development and test bed using Kind. For those who are not familiar with it, I highly suggest taking a look at it. There is a Kubernetes SIGs org. Underneath that Kubernetes SIGs org, there's a subproject called Kind that basically allows you to have a developer desktop version of Kubernetes stood up in the same manner that we are actually using kubeadm to deploy standard clusters. But it's far faster, far cleaner for using just a localized development setup. It's also super useful if you are starting to develop CI integrations that actually require clusters. So what's beneficial of this is, and there was a lightning talk yesterday, I believe from Marco, was that you can integrate this directly into Travis CI. All you need is a Docker socket endpoint, and then it basically fully jumps inside its own belly button and starts to fork a whole cluster. Right? So it's an interesting way of solving the problem by only needing one requirement. Some of the other things with kubeadm, we already have HA implementation. We're going to try and push that to graduate to GA. We also want to graduate the configuration to GA as well, to be basically V1 versions of API configurations. As I mentioned earlier, Lucas is doing a lot of good work with regards to standardizing how we deal with configuration of the components across Kubernetes. And I hope over time that things that are even higher up the stack could be able to leverage this as another reusable toolbox for how they do standard configuration of other elements that build atop of Kubernetes. Again, it's all about the composability, building the toolbox that other people can leverage. And the work group is starting soon. Yeah.
For the cluster API, we're really focused on getting an alpha API version cut with solid implementations across multiple environments, and then pushing that to beta before the end of the year. There's also quite a bit of interest in adding more providers. And in particular, you might have noticed that something like bare metal was not on the list of existing providers. There's been quite a bit of interest over the last couple of days of people saying they want to work on bare metal. The folks from Platform 9 and Samsung have been working on an SSH provider, which sort of approximates bare metal, and have some plans and ideas of how they can push that even further over the next year. And finally, with KubeSpray and COPS, these are some of the major sub-projects in our SIG. We are working on, there goes the slides. We're working on getting them to sort of start adopting the various layers that we're building. So each of the other layers you see above on this slide are sort of component pieces. And when we look at something like COPS, it sort of provides the whole shebang, right? It's the whole cluster management tool. And what we'd really like to do is to start replacing pieces of that with components that are shared across the ecosystem. And over time, if we can be successful, then something like COPS and KubeSpray start to converge, and they start to look like very similar tools. And having that convergence is great for a number of reasons. First, it provides a similar user experience for people, regardless of which tool that they started with. It can potentially provide you the ability to move between tools during different parts of your cluster lifecycle. And third, it allows the community to sort of focus on building new support in a single place and getting that new support to people regardless of which tool they started using. So wait, there's more. There's lots of talks related to our SIG this week. There's a talk that Chris and Loke are giving, looks like this afternoon, about running the Cluster API on-prem and on cloud. There are intros and deep dives into various sub-projects. So tomorrow there's an intro for Minikube, and there's a deep dive on KubeSpray, and Thursday there's deep dives for kubeadm, Cluster API, and finally a talk from Jeff and Justin about operators and add-ons.
This list isn't complete too, so yes. Check the schedule.
Great. And we finished early, which was our intent, because as Tim mentioned at the beginning, being part of the maintainers track, we really want this to leave some time open for questions, and have people ask us questions about, if you have other questions about how to get involved, if you have questions about projects we didn't talk about enough, or we whet your appetite and you want to know more, please do ask us questions now or find us afterwards.
I will run around with a mic, so feel free to raise your hand and I'll try to run around.
Yes. Yes, and again, this is not a complete list. These are ones that we just sort of pulled up until we ran out of space on the slide.
So are there questions?
Oh, excellent.
So on Cluster API, I noticed a few things. The first is that it's all of the cloud providers have forked API, and they provide base implementations for that. And I'm wondering when you think you're going to stabilize on an interface that people can just plug into so that you have like a pluggable interface, and also kind of when you think you're going to what's the timeline for zeroing in on your stable API?
Yeah, so when you say they've been forked, what you notice if you look at the list of projects is that they are separate projects for each provider. And that was actually done on purpose. One of the lessons we learned from Kubernetes core was that trying to put provider support for every provider into the same monorepo doesn't scale very well, right? So when someone wants to make a change, it becomes very difficult to put that into the main repo. And you're also vendoring all the libraries for every single different provider environment. So the core Kubernetes repo is actually in the process of trying to break out all the cloud providers and push them out of the main repo into their own things, right?
But it's my understanding that every provider provides their own implementation of the API. That it's so that there's not a pluggable interface that loads the code in, but it's actually cloud provider gives you cluster API code, and that's like their entire
I see what you're saying.
cluster
Okay.
API code.
So there are a couple different layers there. So we have something that's called the provider actuator, which is an interface where you actually have to put your cloud provider specific glue. And right now that's compiled into the machine controller, which is one of the 3 controllers that we run as implementing the API. There have been a number of proposals to split that out into a separate binary. So we'd have a single binary that was compiled from the main repo that was a machine controller, and you'd run your actuator code separately, either via webhook or via gRPC. There are a number of folks in the Cluster API meetings that are proposing different ways to do that. I think that that's sort of the trajectory that we're on. As far as the API being stable, we're still trying to get a couple of different changes into the API before we call it stable, because once it's stable, we do want to be able to support compatibility. And it's much easier for us to iterate quickly if we are not promising any sort of compatibility. The other thing there is we've migrated back to CRDs over the last year, and CRDs don't currently support version conversion between different versions of the same resource. So if you want to go from Alpha 1 to Alpha 2, CRDs don't yet support a way to translate that on the server side. That is coming soon, and once that's in place, it'll be much easier for us to say, here's our API, and we can support you going forward by migrating your data. That was actually one of the main reasons we weren't using CRDs earlier this year, but since that support was being added to CRDs very quickly, we decided to switch back.
The question I have is, I'm also new to kubeadm. So kubeadm will be used to deploy the composable Kubernetes cluster on single provider, and is it possible that it will expand the same Kubernetes cluster across multiple provider, or we will be able to deploy multiple Kubernetes cluster across multiple provider and use some sort of federation whose management will be kubeadm?
Yeah, so I think the second one is the approach that we would recommend. Since very early days in the projects, the Kubernetes cluster has not really been designed to span across wide area networks or across multiple providers. And in fact, as one of my former colleagues mentioned during his talk right before this, initially it was scoped to like a single availability zone. We've gradually added support where you can actually run Kubernetes across multiple availability zones within the same region. That's tricky on cloud providers because you have things like persistent disks that really can't move across availability zones, right? But we do have support in Kubernetes for correctly labeling and mounting disks correctly, so you can run a cluster across a region. But a single cluster is not designed to run across multiple regions or across multiple cloud providers. So kubeadm can be used to build a cluster that spans multiple availability zones. You could use it to build a cluster that spans larger areas, larger wide area networks, but it's not really recommended.
Related to this, so where do we draw the boundary, right? Can we expand one Kubernetes cluster across racks or across data center or across region? Definitely we got answer, we should not expand it, say, across multiple providers. So in your experience, or what are your suggestions regarding that, till where we should put a limit to, okay, this is...
This varies widely. So like there's certain opinions. We build tools for people to construct models that make sense for their environment. The problem comes in a pace of like, we have certain best practices, but then we have to stop at a certain line because your requirements are yours, right? We can make recommendations, but we don't actually, say there's a hard and fast rule for some of these things, because sometimes by breaking those rules, people come up with interesting, unique solutions that never existed before, right? And sometimes it's just crazy. But crazy is a way to innovate, right? So not all crazy is terrible. Some there's good crazy and there's bad crazy, right? So so being able to innovate, we don't put rules or boundary lines on it. So it's up to an implementation for a provider in something like Cluster API. kubeadm, you can do anything. It's lower layer in the stack that allows you to set up and manage your cluster in any way you want to. Most of the providers for Cluster API will bake in some suppositions about how they think of best practices for that given provider, right?
Yeah, I mean, I think as Tim was saying, there you might have a strange use case where it will work for you, but for the most part, like all of the sort of the default timeouts and health checks and so forth are really designed for a low latency environment where you don't have a lossy network, right? So running across providers where you have increased latency and increased packet loss, you're going to start to see things like eviction thresholds get hit when maybe they shouldn't be hit, right? And your cluster may not be as reliable. On the other hand, you can always go in and start tuning those things to make it work for your requirements if that's what you need. Just like sort of the out of the box experience is not tuned for that sort of environment.
I think one of the things we have seen over time too is the idea of, instead of having like this single spanning large cluster, is the idea of having multiple clusters and be able to manage that in a programmatic fashion using things like Cluster API is actually beneficial. And how you do sort of traffic routing and traffic shaping across these clusters is it simplifies the problem. Then you keep your failure domains are isolated, and you also have the ability to like think about composable models in that space as well.
Right. Yeah, I think failure domains is a great point, because one of the reasons we tell people to run multiple clusters is then you can do things like upgrade a cluster and it breaks and you still have your other clusters running your application, right? And if you're load balancing your incoming traffic, you aren't having an outage if your cluster breaks during an upgrade. We can sort of hear you. Speak loudly.
I was hoping you'd talk a little bit more to the composability story around those cloud provider implementations. So like when they make a reasonable default choice, but let's say I need to override it because my company does something specific, hypothetically.
Sure. So I think all the implementations I pointed to are all open source, and the interface between sort of the common code and the cloud provider code is really narrow. And so the idea there, like for AWS in particular, there are a couple of different ways people have decided that they want to implement that narrow interface. And so I think, was it flavors? Is that what we called it?
It's variants.
Okay. So within the different providers, like we have a provider sort of maps to an environment. So like Google, Amazon, maybe bare metal, and within a provider, you might have multiple variants of how that provider is instantiated. And so for AWS in particular, people already have ideas, like multiple ideas of how they want to implement the provider. We're trying to consolidate those into a single repository so that we can share as much code as possible, because there's a lot of common code dealing with the AWS APIs. But that would give you some flexibility, and then if you needed to do something different, you could either try to push that code into the same provider, or you could fork the provider, or you could run something else that implements that sort of minimal interface, especially to the earlier point, as we break that out into a separate binary, you don't have to compile in everything else.
Hey, this is more out of curiosity. Has there ever been a push from the community to kind of come together and have a common integration with the providers? So then we wouldn't have to break out, like most of the code's duplicated across all the providers. It's just that end integration, like the end API call, is different.
You mean like integrate the cloud providers?
So basically, you could think of it as like putting a wrapper on all the cloud providers and like making the API call work for that one provider.
So there's good crazy, and then there's the crazy.
That would.
This kind of delves into the crazy, not necessarily because it's been tried. It's kind of like watching Dune. They tried and failed. No, they tried and died. There have been many solutions that have existed over time. Apache projects. If you go back in time, again, this will start to date myself. There were other technologies before the major cloud providers even existed that tried to mimic and have a single abstraction layer. I'm ex-Red Hat, and that technology used to be called Delta Cloud, and it burned terribly. Then there were other projects that existed that are Apache projects to try and give you that single provider abstraction layer. I think the problem is providers have very strong opinions about how they want to do certain implementations behind things, and the idea, they're not necessarily compatible from viewing from A to B to C. Now, it's possible that we might be able to get enough of an abstraction layer, just enough for us to do what we need to do. But I think what happens over time, typically in SIG cluster, this is where the good crazy comes in. Over time, when you start to have this fragmentation, common patterns start to emerge. And from those common patterns, we might be able to, just like we did with kubeadm, distill down that into a certain, accrete that into a certain layer so that it's reusable across all of these things.
Yeah, I'll also point out that in the main Kubernetes repo, we do have something called the Cloud Provider API. And so there is an API layer that tried to do sort of exactly that. and have common code that called out for each of the different providers. And at some point, it became unmanageable, and we stopped allowing new providers in and started looking for better ways to manage it. And the way we came up with was you, in Kubernetes, would declaratively say what you want, and then a controller would actuate that for you. And instead of having this sort of common controller code in the controller manager, we'd run a cloud controller manager that provides that glue. And we can have a common controller sort of runtime framework where we try to minimize the delta for each cloud provider. But we do really want to break that out of process and out of tree and make them be able to innovate and iterate on a lifecycle that's separate from the main project lifecycle.
Don't get me wrong, I would love that for it to happen. It's just from a commercialization perspective, I've been watching this ecosystem evolve since the baby years, and they have vested interest to not.
Yeah, again, I was just curious if that ever tried to happen more than anything.
Yeah, that's sort of where the project started out. Actually, was much more along those lines, and we'd have a call, check for load balancer, and you'd implement it for GCE, and you'd implement it for AWS, and you'd implement it for Azure, and if you see the sort of list of cluster API implementations, like it just gets longer and longer, and becomes sort of untenable, and then you get a sort of single set of code reviewers and a huge bottleneck, and people can't continue to push code when they're trying to fix bugs. Right?
I'll repeat for the video. SIG Cloud Provider, which is having a session on tomorrow and also on Thursday, is actively working towards getting all of these providers out of entry and making, a full set of external providers that, using the Cloud Controller Manager yeah. So if you're interested in that sort of work. Thanks.
Just curious, you mentioned bare metal a couple of times. Do you envision bare metal as a provider to a provisioning system, or rather a Kubernetes native way to actually,
So David Watson from Samsung has quite a few ideas on how to do this. So I would encourage you to come to the deep dive on the Cluster API on Thursday and ask him that question.
There's other solutions and integrations that haven't been fully flushed out yet. If the problem with on-prem is it gets kind of fractal. And there are many legacy solutions, and people have their own legacy systems. So one of the things that we talked about in the main Cluster API meeting is the idea of having hooks for different lifecycle events. And provided that we standardize and have a clean hook mechanism, it would allow any provider for on-prem environments to be able to hook into those lifecycle events. So if you wanted to start doing Pixie booting machines and standing up from absolute zero, you should have that support or capability. It just hasn't been fully. A lot of people haven't prognosticated or put their implementations out in the wild. There's also the notion, if you're looking for more cloud native type of solutions, the digital rebar is one of those technologies that folks have mentioned as a potential integration for that cloud native like on-prem environment.
Great. Lucas just reminded me that we're about 7 minutes over time and eating into people's lunch. So please go get some food so you're ready for this afternoon. And if you have more questions, feel free to come up and chat with us. Thanks.